More on right triangles in this section. So a right triangle, you probably already know this, but let's talk about it anyway, is a triangle with a right angle in it. In a right triangle, the side opposite from the 90-degree angle, the longest side, is called the hypotenuse. If we name a theta an angle, if we're in here, we're just going to pick this one. Then the side that makes up one of the angles is called the adjacent side. It's adjacent to it. And then the side of the right triangle that's opposite from the angle is called the opposite. We can also call each of these sides A, B, or C. Usually C is our hypotenuse and A and B are our sides, and they're pretty interchangeable depending on where theta is. But sine of theta is equal to the opposite side's length over the length of the hypotenuse. So A over C. And that will always work in a right triangle to find the sine of an angle. Cosine of theta is equal to the adjacent over the hypotenuse. And tangent is equal to opposite over the adjacent. Then cosecant, secant, and cotangent are just vice versa. So since sine was opposite over hypotenuse, cosecant is hypotenuse over opposite. Secant is a hypotenuse over adjacent, and cotangent is adjacent over opposite. So for example 1, we want to find the 6 trig values in this figure. We've got the length of 2 of the sides, but we don't have the length of the hypotenuse. So we're going to use the Pythagorean Theorem to find the hypotenuse. So we've got 3 squared plus 4 squared equals c squared. So c will be the square root of 9 plus 16, which is the square root of 25, which is 5. This is one of those triangles you can remember pretty easily. If the lengths of your sides are 3 and 4, then the hypotenuse has to be 5. It's a 3, 4, 5 triangle. There's also 5, 12, and 5, 12, 13s, and any multiples of those two. So sometimes it cuts down on your work a little bit. So now we're going to find the 6 trig functions. So sine of theta, and realize that theta is right here, is equal to the opposite, that's 3, over the hypotenuse, that's 5. Cosine of theta is equal to the adjacent, that's 4, over the hypotenuse. And tangent is equal to the opposite over the adjacent. Then for the other 3, cosecant is equal to the hypotenuse over opposite. Secant is hypotenuse over adjacent. And cotangent is adjacent over opposite. For our last example today, if we've got tangent of theta is equal to 5 over 12, we want to find secant of theta. Okay, well, let's assess what we've got here so far. We've got the tangent is equal to 5 over 12. We know that tangent is equal to opposite over adjacent. So that tells us that the length of the opposite side is 5, and the length of the adjacent side is 12. We're trying to find secant, and secant is the hypotenuse over the adjacent. So we've got the adjacent is 12, but we don't know the hypotenuse. So we have to find it. This is one of those special right triangles. It's a 5, 12, 13. So we know the hypotenuse is 13 if you knew that. But if not, you can use the Pythagorean Theorem. We'll just take 5 squared. Oh, let's draw a picture. So if we've got this triangle, the opposite is 5 and the adjacent is 12. And so we're trying to find C. So C squared will be 5 squared plus 12 squared. So C is the square root of 25 plus 144, which is the square root of 169, which is, as I said, 13. So now we know we can plug in the 13 here, and the secant of theta is 13 over 12.